So in the previous video, we learned that computing confidence intervals for statistics like median, variance or standard deviation, uh, and for 90th percentile are non-trivial, right? So since the advent of modern computing and programming, since the time we had modern computers at our disposal, people have come up with programming-based techniques, programming and simulation based techniques to compute confidence intervals. Remember, most modern computing and programming has become widely available in the last 60 to 70 years. Prior to that, people were doing everything, even a lot of statisticians didn't have computers at their disposal prior to that, right? So since computers became very, very popular and programming and simulation tools and modern programming languages have become very popular, more and more people today compute confidence intervals using the empirical bootstrap method, which is a computational method, which basically means that it requires computers. It's a computational method, right? And it's a very, very popular, very, very powerful method through which you can compute confidence intervals for lots of statistics, not just means and medians. You can also compute for very, very complex things. We'll see as we go forward. We'll see how we can compute confidence intervals in other important statistics. But right now, let's just focus on median for now. Okay, so let's start with an example. Imagine if I have a random variable x which has a distribution f, right? Now my task is to estimate the confidence interval, the 95% confidence interval for the median of x. The median of x, not the mean. Remember, it's not the mean, it's the median of x. Okay, now with that task, let's see how we can go ahead with it. Okay, now given my random variable x, let's assume I have a sample. Let's assume I have a sample of size 10. Okay, so this is the sample. This is the sample that we saw earlier. We had x1, x2, so on and so forth, xn, right? With n equals to 10. So I'll take with random values with a value of n, and then I'll show you some example with the heights data set of 10 random heights that we picked. I'll show you some code example at the end of this video. Okay, let's assume I have a sample of size n. I'll just put a general value n here. This is my sample. Just using this sample, using only this sample, this is the only thing that I have. Using only this, I need to compute the confidence interval of median of x. Just using this, nothing else. I don't know what distribution. I don't know the distribution type. I don't know what is the type of distribution. I know nothing. I just have n values. Let's assume n is reasonable. N is not like 1 or 2. Let's assume n is reasonable, 10, 20, preferably 30, 40. The larger the n, the better it is. Okay, so as n increases, you'll be able to estimate the confidence interval of your median better. Okay, so but let's see, just given this, using only this sample of size n, how do I compute? The first step that you do is you start generating samples using from this sample. Okay, this might sound a little confusing. So we take this sample and we generate new samples from this sample. Okay, so for example, I can generate a new sample x1 1. This one corresponds to this one from my sample 1. Okay, x2 1, x3 1, so on and so forth, xm1. Okay, such that m is less than equal to n. Now, how do I generate this? So remember, this is a random sample. This is a random sample of size m, generated from, let's assume this sample is called S, capital S. Okay, generated from S. Okay, so let's assume if m is 5. Okay, so I randomly, which basically means, and let's assume n is 10. Let's assume n is 10 and m is 5. So I can pick half of these values uniformly at random. Okay, if I have 10 values, right? So when I pick the values, some values may repeat here. That is called sampling with replacement. Okay, so some of these values may repeat. That such a repetition is called sampling with repetition. Okay, so what I do here is I pick each value, and each value since our original sample is only of size 10, this is the best we can do. It's a very, very simple code snippet, extremely simple to compute confidence interval of median using empirical bootstraps.